Hello everybody, welcome into another lesson. So today we are going to talk about complex fractions. Complex fractions are basically you have a fraction in the numerator and a fraction in the denominator. Really all these are another fancy way of writing a fraction divided by a fraction. So whenever you have a fraction divided by a fraction, your first fraction, the one in the numerator, stays the same. It would be m over 8. But you invert the fraction in the denominator, inverted 5m over 8 would be 8 over 5m. So you're going to take m over 8 and multiply that by the inverted fraction of 8 over 5m. Well, it's clear the 8's cancel out. And then between m and 5m, the m's cancel out. So what you should get is 1 over 1 times 1 over 1 over 5, excuse me, which that would reduce to 1/5. So the answer you should get for this would end up being 1/5. Alright, what's next? Similar one, we have 3a over 4, all that divided by 15a all over 12. So, this complex fraction, you have 3a divided by 4 all over 15a divided by 12. Well, your first fraction in the numerator is going to stay the same. It's going to end up being 3a over 4 times the inverted fraction in the denominator, which would be 12 over 15a. Okay, start with, I think we can see the a's are going to cancel out. 4 and 12, 4 is a common factor of 12. You divide 4 by 4, you get 1. Divide 12 by 4, you get 3. And then between 3 and 15, 3 is a common factor, so divide 3 by 3, you get 1. Divide 15 by 3, you get 5. So what you should get is 1 over 1 times 3 over 5, which would simply become 3/5. So the answer to this would end up being 3/5. Alright, let's see. We have u over v squared. That fraction all over u over v. Okay, so we have u over v squared all over u over v. So what you're going to do, keep your fraction in the numerator the same. You'll have u over v squared times, you'll invert that fraction in the denominator. That would become v over u. Well, I think it's safe to say the u's cancel out. That's going to be a no-brainer. But between v squared and v, you have a common factor of v. You divide v by v, you get 1. Divide v squared by v, you get v. So what you should be left with now is 1 over v times 1 over 1, which in the end should just give you 1 over v. And that would be your answer, would be 1 over v. Alright, let's see what we can do now for other types. Let's see here. We have 3 all over x, 3 over x all over 1 all over x minus 1 over 3x. Alright, so now this changes a little bit. We have 3 over x all over 1 over x minus 1 over 3x. Well, before you invert and multiply, what you're going to want to do is, for the fractions in the denominator, come up with your least common denominator. Between x and 3x, I would definitely say 3x would be your least common denominator. So what we do here, keep your fraction in the numerator the same, that 3 over x, let that go for now. Now we need to convert that denominator of x into a 3x. In order to do that, you multiply by 3, you'll get 3x. You take that numerator of 1, multiply it by 3, you'll get 3. And then you have 1 minus 3x, which already, 1 over 3x rather, which already has the least common denominator. So now we have the least common denominator. We can go ahead here, perform the subtraction in the denominator. You'll still have 3 all over x. All over, see, 3 minus 1, that's going to be 2 over 3x. So what this reduces to is 3 over x all over 2 all over 3x. Now we can take the fraction in the numerator, we can leave that alone. You'll have 3 over x times the inverted fraction of what's in the denominator. That would be 3x all over 2. Let's look for anything that'll cancel out. The only thing that strikes me would be the x's. The x's would cancel out. That would give you 3 over 1 times 3 over 2, which in the end should end up giving you 9 over 2. So the answer you should get for this would end up being 9/2. Alright, we have n squared minus 25 over n all over n minus 5. Alright, so we have n squared minus 25 all over n of that fraction all over n minus 5. One thing to realize, if you only see one expression in the denominator, you have a default denominator of 1. So this can be rewritten as n squared minus 25 over n all over n minus 5 all over 1. It can be rewritten as that. Okay? First thing I would do, well, let's go ahead and invert and multiply, okay? You'll still have your n squared minus 25 all over n, but you're going to invert and multiply the fraction in the denominator. You would have times 1 over n minus 5. Now, it doesn't look like we can factor just yet, but we can definitely factor n squared minus 25. That factor is going to be the quantity of n plus 5 times the quantity of n minus 5 all over n. Then you'd have times 1 all over n minus 5. So now that we have factored that n squared minus 25, we have a common factor of n minus 5 in both the numerator and denominator. Those will cancel out. So what you should be left with is n plus 5 all over n times 1 over 1 which would just simply give you n plus 5 over n. And that would be your answer, would be n plus 5 over n. There's no further way to factor this. All right. Let's see here. We have 2w over 3 plus 2 all over 5w over 3 minus 15 over w. So we have 2w over 3 plus 2 all over 5w over 3 minus 15 over w. First, consider the fractions each at a time. Start only with your numerator first. That plus 2, well, the default denominator is 1, right? Your least common denominator between 1 and 3, that's going to be 3. So you can leave the 2w plus, you can leave the 2w over 3 alone. That's already got the common denominator of 3. Alright, plus, now, that denominator of 1 on the 2, we can make that into a 3 by multiplying by 3, but you got to do that to the numerator of 2, you would get 6. So now you have 2w over 3 plus 6 over 3, all that, all over the fraction in the denominator. Okay, let's look only at the fraction in the denominator. You have a denominator of 3, you have a denominator of w. So what's going to be the least common denominator? 3w. In order to make that denominator of 3 into 3w, well, we got to multiply by w, so you would get 3w. Okay. And then you got to take that 5w, multiply it by w. Well, you'd actually end up getting 5w to the second. Now, minus, we need to convert that w into a 3w. So we have to multiply the denominator by 3. You'll get 3w. But what you do to the denominator, you got to do to the numerator. You would end up having 15 times 3, well, that'd be 45. Alright. So now, what you're going to have when you add these together in each the numerator and denominator, you'll have 2w plus 6 all over 3 all over 5w to the second minus 45 all over 3w, okay? Now we've got it to a point where we can invert and multiply. Keep your numerator fraction the same, that'll be 2w plus 6 all over that 3 times the inverted fraction in the denominator, that would be 3w all over 5w squared minus 45. Well, right away we notice between the 3 and 3w there's a common 3 that factors out. So that makes your life a little bit better. Let's go ahead a little bit further. Let's factor each of these, the numerator and denominator out. 2w plus 6, you have a common 2 that'll factor out. You would get 2 times w plus 3. You get that over 1 times w all over, now 5w squared minus 45, that'd be 5 times w squared minus 9. But what do you know? the w squared minus 9 factors a step further. I'm going to bring it over here. You'll have 2 times w plus 3 all over 1 times w all over 5 times w plus 3 times w minus 3. Okay? Well, now it's plain to see we have a w plus 3 that cancels out between the numerator and denominator. So in the end, what you should get for your final result is going to be 2w over 5 times w minus 3. That would be your end result. That'd be 2w over 5 times w minus 3. And that's as far as we can go. That's as far as we can factor. Alright, let's see here. Let's do a couple more. Let's do 2 more. So we have 2 all over z plus 1 minus 2, all that all over 2 minus z all over z squared minus 1 minus 2. Okay? Again, take these fractions one step at a time. Start in your numerator. That minus 2, that has a default denominator of 1, does it not? So between 1 and z plus 1, what would be your least common denominator? Definitely z plus 1. So you can leave the 2 over z plus 1 alone. Now, that denominator of 1, you multiply it by z plus 1 to get said denominator, but you got to multiply that 2 times z plus 1. 2 times z plus 1 is 2z plus 2. I'm just saving us a little bit of work here. Okay? You're going to do that all over. Now let's deal with these fractions here. You have, of course, z squared minus 1 and that default denominator of 1. Plain to see your z squared minus 1 will be your least common denominator. Well, 2 minus z over z squared minus 1 can be left alone. Minus, okay. We have to make that second denominator become z squared minus 1, which means we got to multiply that 2 by z squared minus 1. You would end up getting 2z squared minus 2. That's the answer you would get. So now, in each of these, we can go ahead and we can add and subtract these fractions in the numerator and denominator. So, let's see, 2 minus 2 is 0. You would just end up getting negative 2z all over z plus 1. That all over, let's see, 2 minus negative 2, that, well, we'll deal with that in a second. You have negative 2z squared minus z. Then you have 2 minus negative 2. That's actually going to be plus 4. Then, of course, you have your denominator of z squared minus 1. Well, now we can invert and multiply. You'll keep your negative 2z all over z plus 1, but you'll invert and multiply the second fraction of the denominator. That'd be times z squared minus 1 over negative 2z squared minus z plus 4. All right. Well, let's look here. We can definitely factor the z squared minus 1, right? We can definitely do that. You'd end up having negative 2z all over z plus 1 times your quantity of z plus 1 times z minus 1 all over negative 2z squared minus z plus 4. Okay, well, it's clear that a z plus 1 cancels out between the numerator and denominator. And if we look at the denominator real quick, that negative 2z squared minus z plus 4 doesn't factor any further. You could go ahead and try it. You won't find any factors that work. So what you're going to have in the long run, you'll end up getting negative 2z times z minus 1 all over. You can factor out a negative, I suppose. Factor out a negative from the denominator. You would have 2z squared plus z minus 4, which means the negatives will cancel between the numerator and denominator. You could get 2z times z minus 1 all over 2z squared plus z minus 4. And that's as far as you can factor. You get 2z times z minus 1 all over 2z squared plus z minus 4. Alright, and then I did have one more, and then we're done for the day. What was that one I wanted to do? Oh yeah. So we have m minus n over m plus n plus n over m all over, we have m over n minus the m minus n all over m plus n. That one looks hideous, I'm not going to lie, it does. Well, consider each of these in the numerator and denominator separately, okay? You have two denominators in the numerator. You have m plus n and just plain m. The least common denominator is going to be m times m plus n. So we'll go ahead and do that for the first expression in the numerator. I had to multiply by m, which means I have to multiply my numerator by m also. Alright, plus, now, let's see, I need to make that m become m times m minus n, which I'm about to do just that right now. M times m plus n which means I got to take that n in the numerator and also multiply that by m plus n. I'm going to have all that all over. Now, consider only the denominator, m over n minus m minus n over m plus n. Well, you have a denominator of n, you have a denominator of m plus n. Your least common denominator would end up being n times n plus n. So I'm going to make that first expression, the first term in the denominator, have n times m plus n, which means I need to multiply that numerator of m times m plus n minus. Now, I also need to make that second fractional expression have a denominator of n times m plus n, which means I've gone ahead and multiplied that m plus n times n. So that means I got to take that m minus n multiplied by n. So far this is what we have. I know it doesn't look pretty, but this is what it is. Let's go ahead and work in the numerator to start with here, okay? Got to add these together. So m times m, that's going to be m squared, right? We have m squared minus mn, plus we have n times m, that's mn, plus n squared, all over m times m plus n, right? All that all over. Now let's deal with the denominator. Distributive property, m times m, that's going to be m squared plus mn. Then you have n times m, which would be mn, but you have a negative, that'd be actually minus mn. Then you have n times negative n, that's negative n squared, then negate that, you'll have plus n squared. You have that all over n times m plus n. Okay. Well, let's simplify before we invert and multiply. Notice in the numerator of the numerator, negative mn and positive mn, those will cancel out. What you're going to be left with is m squared plus n squared all over m times m plus n. You're left with that all over. Now let's look at the numerator of the denominator. mn minus mn, that's 0. You're left with m squared plus n squared all over n times m plus n. Starting to see it's not so bad. Now, we've got it to a point we can go ahead and invert and multiply. You'll keep your numerator fraction the same of m squared plus n squared all over m times m plus n, but take that times the inverted fraction of the denominator, that would be n times m plus n all over m squared plus n squared. Well, right away we have an m squared plus n squared in the numerator and one of those in the denominator. Those will cancel out. What else? We have an m plus n in each, the numerator and denominator. Those will cancel out. So in the end, all you're going to be left with is n over m. And that would be your final answer, would end up being n over m. All that work just to get n over m. Sometimes you'll have that, but if you understand that complex fractions are just a fancy way of dividing fractions, and you can get a least common denominator in each, the numerator and the denominator of your complex fraction, you should be good to go. Next lesson, we will move into algebraic ratios. So I hope everyone has a good night. Take care.